Welcome to the ftir.fun Infrared Learning Series. This episode, Ep17 Data Fifth Instrument Operating Procedure, General for F, then close with a checklist. Next, IU, a hand that touches the instrument. 4. The first time. Trainers love to tell a story. His student Zhang had been doing synthesis for 3 years, and for the first time he approached ARLV, staring at the control panel full of buttons. Palms, sweating, which button to start. This stranger effect is very common in eye lobes. FTIR instruments look like mini refrigerators. The control panel is simplified to just a few buttons, and the software interface appears complex. This simple plus complex combination often leaves people unsure where to start. Next, startup procedure. Waking up the instrument. Startup is not just pressing the power button. Before powering on, the following items must be checked. Environmental check. Room temperature 25 degrees C, recommended 22 degrees C. Stable plus or minus 2 degrees C. Relative humidity 60%, mass 40%, no strong air currents in the room. Avoid fans blowing directly at the instrument. No vibration sources on the instrument bench. Next, dye spectrum. Zeroing before measurement. 2.1. What is a background spectrum? Infrared spectroscopy measures the absorption of the sample, but the instrument itself and the air in the optical path also absorb our light. To obtain pure sample absorption, these non-sample factors must be subtracted. Next, parameter settings. 3 knobs that determine spectral quality. FTIR measurement has 3 core parameters: resolution, number of scans, and spectral range. It directly determines spectral quality, measurement time, and data size. Physical meaning of resolution: the minimum wave number difference at which the instrument can distinguish two adjacent. Next, sample measurement procedure. 4.1 Transmission method. Sample measurement steps, using cable palette as example. Next, V. Data file formats. FTIR software from different manufacturers uses various proprietary formats, but also supports universal formats. 5.1 Major manufacturer proprietary formats. Next, VI. Thermo-Nickel IS50 operation example. Below is a complete operation about using the Thermo-Nickel IS50 as an example. Set in Omnic main interface. Number of scans 16 or 32, resolution 4 cm, spectral range 4,400 cm, background mode. Collect before each measurement. Recommended detector DTGS automatic. Next, V. Bruker Tensor operation example. Below is an example using the Ep17. In Opus advanced measurement window, number of scans 16 or 32, resolution 4 cm, spectral range 4,400 cm, meteor detector RTGLATS default, beam splitter K-belt, sample mode, absorbance background mode, single background, recommended per measurements. Next, shutdown and daily maintenance. Standard down sequence. I came in, without purge, exit software, save all data. Turn off instrument power, turn off computer, turn off main. Notes: Zik and long-term shutdown. 1 week. Place desiccant inside the instrument. Short-term shutdown. 1. Day keep purge at low flow. 1 L-min is sufficient. Do not frequently power on off. Each time the source needs 30 minutes to stabilize. Next, best practices for operation. Cream measurement. Check before the first sample each day. Measure a polystyrene film to confirm instrument status. Confirm background is valid. 1 hour old. Data recording record sample information. Sample preparation, conditions, and operator in file metadata. Use experiment notebook to record anomalies. Next, safety precautions. Laser safety topping 4 contains a Hana laser 632.8 nanometers 1 mMu. Class 1. Class 1 is safe under normal use. To avoid direct eye exposure to beam path, do not open the instrument beam path cover. Power safety eye in ensure proper grounding, use ups uninterruptible. Power supply, avoid voltage fluctuations. Next, zone for reflection. You are a new lab operator using Ep17 for the first time. After powering on and waiting for the light source to stabilize, what preparations should you make? During an experiment, you suddenly notice a distinct double peak at 2,350 centimeters. But this was not present before. Measurement, analyze possible causes, and provide solutions. That covers the required sample for this episode. Practice with real spectra on ftir.fun and continue with the next lesson.